Okay, in this video, we're going to look at the part B of the evaluation of this line or contour integral from I to -1. So this time we are integrating along the straight line, joining these 2 points. So let's see how this is going to work out. So integrating from I to -1, we are integrating 2x minus 2iy dz. So let's do a sketch. Sketch is always useful for this type of problems. So integrating from I, of course I has got coordinates 0, 1. -1 has got coordinates -1, 0. So this time we're interested in the straight line joining these 2 points. So that is our contour, our path. So we're going to need to find the equation of the straight line here. So first we can find the gradient of the straight line. Going to be 1 minus 0 over 0 minus -1. It's going to be 1. The y-intercept is 1, so the equation of this is going to be simply xy equals to x plus 1. So then we can, as you can see, this equation gives us x, y in terms of x. So we can opt to rewrite everything in this integral here in terms of x, including the limits. So the y we can already write in terms of x. So there's going to be dy. So if y is x plus 1, dy is going to be dx. So let's see how this works out. So that means the integral from I to -1 of 2x minus 2iy dz is dx plus I dy. So if we write everything in terms of x, this term remains exactly as it is, but this one is going to be minus 2i, y is x plus 1, then dx remains exactly as it is. Dy, we just said, is also going to be dx. Then the limits of x along the contour, x at the beginning is 0 and x the end of the contour is -1. So 0 to -1. Then if we remove brackets here, 0 to -1, we're going to have 2x minus 2ix minus 2i. In this part of this thing, we can factor out dx. Now, since 1 plus I is a constant, we can take it outside. We can factor it out, and then this we can integrate with respect to x. Integral of 2x is x squared. Integral of another 2x there is going to be ix squared. And then integral of 2i is going to be 2ix from 0 to -1. Plug in -1. The lower limit is going to just give us 0 because it's 0. So if you plug in -1, it's going to be 1 minus I plus 2i. It's going to be 1 plus I, and this is going to be 1 plus I. So this is going to work out to I. So that's going to be the value of the integral along C2. Just for comparison, along C1 it was 4I, along C2 it's 2I. Then now let's go to C3. C3 is a parabola defined by a parametric equation. Z of t is equal to t plus I 1 minus t squared, and we are told that t varies from 0 to -1. Since z is x plus iy, what this thing is telling us is that if you compare the real parts here, then you can see that x is going to be t, and then the imaginary parts, which are the coefficients of I, y is 1 minus t squared. Since x is t, then that means this equation we can actually write in terms of x and y. So that's just the parabola. Y is equal to 1 minus x squared. It opens downwards. It's going to have vertex at 0, 1. It's going to have y-intercepts at plus or minus 1. So it looks something like this. Now, our points of interest are I and -1. So this is the segment of the parabola that forms C3. All right. Now, so we've got an equation of y in terms of x. So we could write everything in terms of x, but we've already done that in B. So just for instructional purposes, we're going to use the parametric form where we're going to write everything in terms of t. You're going to notice that when t is 0, okay, then x is going to be 0 and y is going to be 1. So that puts us right there. When t is -1, then x is going to be -1 and y is now going to be 0. So as t changes from 0 to -1, then we trace this parabola, which is going to be the segment that we're interested in. Okay, so this time dx is going to be dt, because x is t. Dy is going to be, remember, y is 1 minus t squared, so it's going to be -2t. dt, we've already said t varies from 0 to -1. So the integral from I to -1 of 2x minus 2iy dz is dx plus I dy. So we can write this now entirely in terms of t, and it's going to look as follows. This is going to be 2t. This is going to be 2I into y is 1 minus t squared. Then dx is just dt, and dy is minus 2t dt. And then the limits are just from 0 to -1, as we've mentioned a few times now. So if we remove brackets in the first term, this is going to be 2t plus 2i t squared minus 2i. And then if we factor out dt here, we're going to have 1 minus 2it dt. This time, well, this term is not a constant, so we can't like just factor it out. So we need to multiply this out first before we can integrate. So if we multiply by 1, these terms are going to be exactly as they stand now. 2it squared minus 2i. Then now multiply by negative 2it. So negative 2it times 2t is going to be negative 4it squared. So I'm going to write that one under this term here because it is a like term. Then negative 2it times 2it squared is going to be plus 4t cubed. Then negative 2it times negative 2i, that's going to be negative 4t. So I'm going to write that one here. So we are going to have integral of 4t cubed is positive. It's going to be minus 2it squared, then minus 2t, then minus 2i. So that's what we are going to have as our integrand. Then we integrate this. 4t cubed integrates to t to the power 4. This is going to be 2/3 I t cubed is going to be t squared, and there's going to be 2i times t. Again, the only limit that's going to give us something non-zero is the upper limit. The lower limit is going to give us 0 right across. So plug in negative 1 here, we're going to get 1. This one is going to be plus 2/3 I minus 1 plus 2i. The i's, or the ones, are going to cancel out, and the i's are going to work out to 8/3 I. Okay, so that's how the integral works out along the parabolic contour. So got 8/3 I. Along the straight line we had 2i. Along the polygonal line we had 4i. What remains to be done, which we will do in the next video, trying to keep these videos nice and short, is part D, where we've got the contour is a straight line defined by this equation here.